Okay, I'm trying to work on these two resistors. Well, actually this one here and that one I've already done. That was the one that was totally messed up, this one here. And it was 60 ohms at a half watt. Of course, I didn't have 60 ohm resistors. So what I did is I put two 120s in parallel, which drops the resistance down to 60. They're both half watts, so now it'll handle up to a watt. Here, I'm not sure what to do. On half of this, I measured 20 ohms. Across the whole thing here, I measured 38, but part of the wire was still in there, and I couldn't make a very good connection on that. And of course, there's no insulator in the coil, so I don't know what effect any of that has on that. So what I'm doing is I've got two 22 ohms here, which will give me a total of 44 ohms across. That's pretty close to what it would be. Probably a little bit less current flow through the resistors than normal. Not much, because that may be exactly what was. I don't know. But either way, what means being higher, if it's a few ohms higher, that ain't a bad thing. So anyway, what I'm doing now is I've got my milliamp meter set up on the center tap. It's going through this white line from the center tap of the two resistors through the milliamp meter back and into the center tap wire here. And we'll check the current going through that line to ground. And then after we check the current going to ground and the voltage, which I'm not bringing the voltage up all the way anyway, then we'll have to check each resistor to see what the current going through the independent resistors are to make sure that a half watt is strong enough. Each of those is a half watt. I don't see where I would need more than a half a watt, but because those were half watt, all the other resistors except the power resistors were rated half watt. So we'll see. Anyway, so let me bring the voltage up. I got it on a station. It'll take the tubes a couple minutes to warm up. Okay, so right now across, I'm measuring the voltage from this one resistor to ground. So that's should be about half the voltage. I'm at 67 volts on my power supply. Actually, let's bring it up a little bit more. I'm not using the current limiting bulb because at this point I already know it's okay. So I'm at 80 volts, which will make it play. It's drawing 660 milliamps at 51 watts. So it's still a little high, and it's playing. It's a little distorted, but it's playing. All right, so we're drawing 25 milliamps through the center, and it's negative voltage, but that doesn't matter. Actually, I could put this on AC. Okay, we're drawing 154 milliamps. That makes more sense. So that's quite a bit, 1.6, 1.5. Oh, it's dropping down. I'm sure one of these resistors is probably getting hot. That one there is getting hot. Okay, so it draws more current through that side, which means that resistor should be higher. So let me shut it off. Actually, I'll just shut it off here. Okay. So now we need to figure out what that resistor is supposed to be. That's most likely the one that burnt out. Let me trace the wire. Sure enough, it's the side that burnt out. So apparently that resistor, this is not a true center tap on the transformer, which here is just showing a tap going to ground. We don't know where that tap is on this coil. It would appear to be center the way it's set up. But again, there's no way to know if that's center. It could be anywhere on a coil. So the fact that this side burnt up and this side didn't seems to imply that more of the voltage is going through this resistor. Current. I don't understand why that would be. Why would more current be going through that resistor? This one's cool, and that one's hot. I don't understand. That really makes very little sense. I am measuring the voltage across that one. And yeah, they're too high. The current's too high. I'm not sure why that is. They're matched resistors. It should be the same temperature on both. It is really strange that it would be drawing more on one side of the transformer than the other. They're an exact match. And I have the milliamp meter on the ground lead. Okay, well, we know what we're drawing through the ground. We're drawing 150 milliamps. And if we do the math on that, it was like, well, if we figure it's half of what it should be, 3.15 volts divided by 150, it was about 152 milliamps. We get, wait a minute, that's wrong. Let me do this backwards. That's the resistance. Yeah, that's strange. Hold on a second. 3.15 divided by 0.152 milliamps. Yeah, 20 ohms of resistance. So that's correct. It's drawing 20 ohms. I mean, I got a 22 ohm resistor, so that's correct. But that should be on both sides, so I don't understand why one would get hot. Apparently the voltage is not evenly distributed, and that makes very little sense to me. Unless there's a short on this side, which would have burnt it out between here and the center tap wire, which is this wire here. If there's a short or a low resistance between these two, then yes, the current would go through. If it was low on these two, the current would take the resistance, the path through that resistor, and that resistor got hot and burnt. That would make sense as to why that resistor got hot. Because if we have a current draw there, actually, I take that back. It would have to be a short or closer to a short on this side, which would put this closer to ground. And if this was close to ground, then I've got all the voltage across here, more of the voltage across here, which would drive this current up. Now I could double this resistor on this side, but that's not the solution. The solution would be to find out why this is close to ground. Let's verify that with the ohm meter. And I'll have to shut this off because I got a lot of voltage in there on those capacitors. Okay, let's check that and see what we get. So what we can do, we measured the current through the center tap. Why don't we measure the current through that particular resistor on that side that's getting hot, and then we'll measure the current on the other resistor and see and compare the two. They should be exactly the same. So let's do that. Let me set up and we'll do that. Okay, I'm set up now and I've got the milliamp meter reading through this side to the center tap, which is here. So from here to the center tap. I've got the milliamp meter in between those two lines. And so we're measuring the current going through this resistor. The white lead will be the current side we're checking. So we're measuring the current going through that resistor. and I got the set off, so we'll turn it on. I dropped the voltage down to 50 volts, so we wouldn't be getting too much current. And we've got 2.8 volts AC climbing across that. It's going to stay right somewhere around there. Okay, 2.9 volts, and we got 107 milliamps of current going through that resistor. So now I'm going to shut it off, and I'm going to set it up for the other side, and we'll check the current on that other side. Okay, now I have it set up on the other side, so the white lead is now on the other side, which we're measuring the current on this one, which you can see going through the meter. So we turn it back on. We have 2.8 volts and 3 milliamps. See that? That makes much more sense. So let me shut it off. That's what burnt up that half of the resistor. There is something going on in the heater string on one half of the heater of one of the tubes. So we gotta find it. Let me shut the power off so I don't get El Zappoed. And I'll set this up to try to find that. One of these heater strings is got a problem. So what I'm going to do is disconnect these two heater lines, opposite lines here, and we're going to, let me get this out of the way, and this out of the way. We know the problem is in this line, so I'm just going to get that out of there because it's a real problem, pain. We know the problem's in this line, so we're going to go ahead and disconnect this line so that we can measure from ground to here, and then I can pull out the tubes one at a time till we find out which tube is the one that has some kind of a short, and I would imagine it's a solder short somewhere, judging by the solder joints that we've seen in this set so far. So we're going to track that down. Once we get that tracked down, then this should be about 3 milliamps both ways, and then at that time I'll install these there, and that's done, and we can go on to tuning the radio. So bear with me. Other than we have to pull these tubes one by one, actually I might just take all of those out that use that heater string and see what reading variation we get to try to isolate a short, and then go from there to installing them back in, because it may not be the tubes. I'm kind of doubting it is. So bear with me while I set up for that. Okay, I've got all the heater string tubes out, I believe. I'm looking through all the sockets. Yeah, I think I got them all. And these are the power supply tubes that use the heater string. Those are 345s, and those two 45 and the rectifier. Okay, so these 4 45, that's a rectifier. All the other tube sockets are empty. And here's what we got. On this wire to ground, we got 1 ohm. On this wire to ground, we got a short, 0.1. So it's in, which would make sense. I was thinking of it backwards, I don't know why, but okay, so 0.9, you figure there's definitely a higher resistance there to ground, and there shouldn't be any than to here to ground. I mean, here to ground we got 0.1, and here we got 1 ohm. Okay, so what that means is that this is the line that's causing the problem. Somewhere along the way, this is close to ground, and or it's probably through a resistor or something. And since this is close to ground, all of the current is going through this resistor, the resistor that goes from here to here, the center tap. I'm sorry, that goes from here to the center tap. This is almost nothing, so the voltage is all across this resistor, which would make that resistor get really hot. So we need to find this wire, we need to trace it through and find out where it's going. And the way I do that is I set up a little pointer that I can grab. Now I haven't discharged these capacitors, but they should be fine by now. So I'm just going to be a little careful. So we know that here we have, well, I'm not going to be able to make as good connection as alligator clips, but you get the idea. We have 0.1 ohms on this side. And here we're now reading 7 ohms. So that's because I'm using this screwdriver. So we know that the 7 ohm side is the good side, and you know, whatever I can get out of it when I touch it, I'm going to get it down to about 6 to 7 or 8 ohms somewhere. So when we go to each heater string that's out, we should see the same readings. And so here the heater string would be 2 and 7. Well, no, it would be okay, there's the 0.1 side, and here's the 1.5 side. So this is the bad side, and we want to keep checking to see if there's any solder glob to ground. This doesn't look like it's been worked on, so that one I think is okay. Let's try this one. No, let me reset my meter. Great. Now let's zero it out too with this screwdriver. Okay, so now when I check across here, 0.8, it's pretty small, right? If I push hard enough, should be able to find a good spot. It's climbing up. Well, that indicates a capacitor to ground. I shouldn't have a capacitor to ground. And here, now we get it reversed, 1.42. What did I move? I moved the wire. Here. Let me just use a clip. Take the chance that I'm not going to hit anything. Alright, so from there, I zero it back out. We want to make sure we got accurate readings. Okay, what's that? Zero it out. Try it again. Sorry for the glare in here. Okay, that's good. So now we're zeroed out. See if we can get this way you don't have so much glare. It's kind of hard to do. Yeah, if it'll stay there, that'll be great. All right, so on this one, 1.9, 1.6, and on this one, 2.8. Okay, so you still see there's a problem with the 1.6 is too low. So, back to where we were. Which one of these is 1.6? That's the 2.8. This one should be the 1.6. Okay, yep. All right, now, up here, that's the weak side, but there's nothing near there. And this one, there's nothing near it. There is a wire going across. Let's see if we can figure out where that wire is going. It's just the heater string wire. Doesn't look like it's shorting anywhere to ground. There's nothing else there. And this one is fine. And I believe that was the 1.6. Let's check that one more time. I want to make sure that we don't have a problem here. Yeah, that was the 1.6 side. And this was the high end. Okay. The only thing I see is, let's see if this goes to ground here. There is a little bit of congestion here. No, that's not grounded. So it ain't shorted to that because that doesn't go to ground. Okay, so continuing up here. Oh, wait a second. No, that doesn't go to ground, and even if the tube was in, it wouldn't make any difference. Here there's nothing on that side. Why am I only seeing one wire there? That's the 1.8 side. Okay, so there's another set of twisted pairs that come up here to this one. And there, oh, I see they're coming from the green wires. Okay, so now they're switching to green on us, from brown to green. Hard to get in there. Okay, that's the high side. And this is still the low side here. Yep. All right, so we'll continue up. That tube looks fine. There's nothing near those wires. You see that one comes from that side. Let me get over there and inspect that wire. Okay, that looks good. It don't look like it's touching ground. We'll pull that away from ground too, just to be safe. Okay, so now we're continuing up to the next tube. The wires come up here. It's this coil here. Nothing seemed to be shorted there. And it comes up to this pin and the one under that capacitor right there. And so we'll check those. Okay, that side we got 2.5. And this would be the low side. No, that's the high side. Okay. So the 2.5 side is where we're going now. I don't know why that jumped up. Oh, we're going through more wire. So yeah, there'd be more resistance. 3.2. Not making good contact. Let's try that again. Can't get on there. 5.3 to there. And here, 1.9. Okay, so this is the low end. And there's nothing there that could be messing with us. So it comes up here. And it goes around there. And it comes over to here. I wouldn't be surprised if it's that one, since we did so much work over there. There's been so many problems over there. Okay. I see a wire that looks like it's cut there. You see that? Oh, maybe that's just a hook. Okay, so let's try that one. That one's 2.3. And this one, 1.6, so it ain't that one. And here comes, let's get a light up there. Alright, that's this one here is the low end, and it's this wire here, it comes up through here, comes around through here, and it goes they go down to this tube here. So let's check them. And one of the filaments is here. And that's 1.0. And the other filament is here. And that's 1.9. Alright, so the bottom one takes the last trip coming over to this tube. And that looks like a suspicious area to me. And it's where people have been working, including myself. That's the 0.8 side. And this one should be a higher resistance here. And that's 1.8 side. Okay, now they're still continuing. They're not done. First off, let's see what's up there. There's a lot in there. Okay, we got another wire coming off there, coming down this way. Okay, we got a wire coming down that way, and we got another wire to here. And we got two on this one. And let me pull that wire away from the chassis back there in case he's making some kind of problem. Get him off the chassis. Alright, he goes here. Oh, that might be hurting it there. Let's pull that away. And they're coming down here somewhere. We'll trace them in a second. Let's look at that one more time. So we'll put this back on this side. We got 0.7. Put it back on this side. 1.7. So it's not that side that you would suspect. It's this combination here. So this wire back here that's going under that ground wire there, do you see it? Goes under that grounded pin there on that tube socket. That seems to be a strange place. Let's see if we can get that off the wire. Remove that wire safely. Alright. And we want to find where it goes. It comes down here. Alright, I want to get by my blog there. I think it's these two that are coming out here. And why would they go to switch? Why would they pull their power from there? Okay, we know it's this one here. So let's trace this and see where it goes. It comes down here and it's so congested, so we got to go by the color of the brown wires coming down. And I have a feeling it's these two coming all the way down here. And they come down here, and they come around, and they come over to here, which would make some kind of sense. They go to that potentiometer, but let's make sure that that's the case. Oh, there's 249 ohms there, so that ain't them. So let's come back and try to track them again. Where can they be going? Actually, they're going up. I was wrong. This was... Okay, hold on. Let me get out of there. They're probably going up to the magic eye. Yes, there's a tap off this. Going up through the board, there's a tap off that one. Go into the magic eye. I didn't unplug the magic eye. Let me unplug it. Okay, I got the magic eye unplugged. And now when I connect up here, I got 0.8 on that side, actually minus 0.8. Let me go ahead and zero this back out. Okay, now we want to know minus number. Okay, so 0 ohms, 0.1, 0.2, and it is minus. So it's 0 ohms there. And on this side, we still got 1.4. So this side is shorted to ground somewhere. Yeah. It's shorted to ground somewhere. And we gotta find it. And that should be the same here. Yeah, 0 ohms. And on here, 1.4. So this one is shorted to ground. And that means that there's some poking around we gotta do to find that. All right, we got this wire going to that. We got this wire going to that. And we got the wire coming in here, which we've traced all the way through. Of course, we traced it all the way through with the tube in, and that kind of changed it, which is strange. I shouldn't have changed it. So, zero that out one more time. I'm still getting negative numbers. It's because I keep hitting this with my elbow and it's affecting it. You know, a tenth of an ohm is just strange. Okay, now I'm getting 0.7 on it. See, I moved some wires. Get on that again. All right, 0.4, 0.2. Let's see if we can get that one. There's no... I had it while I was doing it. Okay, is that better? Yeah. 1.2 now. That's weird. Oh, see what I mean? That connector slipped off. Get on there. I'm not making a good contact, I don't think. 1.2, 3.6. Okay, yeah. We're fine. That's the wire. I forgot we're measuring across all this wire. So we have the wire coming in, which comes all the way around, and we seem to do pretty good on that. We get the wire going up into the socket for the Magic Eye tube, and that looks pretty good. I don't think we're shorted there, but let me move that around and let's see if this moves any. 2.1. No. I'm moving this around to see if there might be a short in this wire, and nope, this wire is fine. Okay, so I didn't think there would be. But now, coming from here, there's a wire coming down. And it goes behind that ground line, and it comes down here. And it looks like it's, oh, it might be this one going to this coil. Oh, don't tell me there's a shorted coil. That'd not be good. Okay, it goes here to that side there. The other one, it's not those two. So this one, we need to make sure that that's the right wire before we assume that that's the right wire. So we'll put this here, and we'll measure there to that coil. Where was it? Right here. No, that don't seem to be it. I can't imagine there being 2 ohms in that little piece of wire. Make sure I got a good connection. Try on that bundle. No. So that don't look like it. But there sure is a lot of low resistance up here. Where's that wire going? It's coming back this way. I don't want to loosen that, and I don't want to move that any more than I have to, because that's pretty good. I need to tighten that after I decide that everything's cool there. Keep that up. So it's coming under that ground wire. It is part of that bundle. Those are the two. So it is these two coming down here. It's either this one or that one. All right, that's that one up there. That ain't it. So it's got to be this twisted pair. Try and grab one of them. I don't see any movement on that twisted pair, though. Let me try from up here. That wire there. That looks like a twisted pair. Yeah, that's saying it's that wire, but I'm moving too many wires to know. I'm probably moving that one. Yeah, I am. So this one is this one here. I don't see it. Where the heck is it going? The dial lights. It's going to the dial lights. Yes, they're right there. They're coming up to the dial light. Going across both dial lights. So that would be that. Yep, there they are, the dial light wires. You see them moving there? It's right here. It's these two. And they're going up to that dial. Oh, okay, hold on. Okay. Okay, that's fine. There's the problem. There's the problem. I bet it's gone now. I bet the problem is gone now. So, let's see. Back to here. Okay, we'll zero it out one more time. Okay, zero it out. Come up to this connection up here that we were looking at, and there's no connection. Come over to here. No connection. We found the problem. Just a second, let me move this back. Okay, we got this connected back up the way it was, and we should have very little current going through the ground string now. I got this back on AC. I'm measuring the voltage across the entire coil. So that's the full filament voltage. And I got this set of milliamp. And let's bring this up now to 50 volts, 60 volts, drawing 450 milliamps, 25 watts. We'll let it warm up. Got 3.5 volts across the filament and no current going through the ground loop. Absolutely 0 volts. So now we're fine. So these resistors will not get hot. They're fine. So we'll let them warm up. And I definitely need to fix that outlet so that it can't short out like that. The way they had it, I took it out, I put the bulb in, I put it back the way it was. I should have known that it was probably wrong. And so part of that was me not following through on that. The customer supplied me the pilot lights, they were missing. He ordered new ones, so I just put them in and put it back where it was. But apparently, whoever had it before obviously had it messed up and burnt out that part of that resistor. That was totally gone before I powered the unit up because I didn't power it till it was recapped. Okay, so we're doing better now. Turn the volume up. Okay. No current draw on that. And let's find another station that has a copyright.
Everything I can. Thank you so much. Jackson said, it's sad to lose, but she gave all in this campaign.
Everything that I'm used to doing, because I felt like I would be a good judge. I know that I would be, but you know what? We prayed our way through it and had a lot of people working with us. I had so many wonderful
Well, looks like the eye light is working.
So much. I feel sad in a way that I didn't win.
We'll check that out as we turn it.
It's the right thing, and I am confident that I will move forward.
Hard to turn that and hold it. Let's see if I can just hold this like this. Maybe we can see that in there. Yeah, it's working, see it? We can't be on that station.
From the northeast Georgia sky, the Classic Car Depot has become a mecca for classic car lovers. You won't believe what you'll find on Washington Street, but did you know you can get your classic car serviced at the Classic
Okay,
Car
I'm going to
Depot?
set that back rail out of the way where it's not going to get hurt.
Antique classic car or hot rod, all of a sudden you can take your beauty anywhere.
So we got a good signal. And that's the fine tuning.
In Clarksville.
In a lot of stations, I don't get all these stations. This is amazing radio. I do not get all these stations on AM radios in this basement.
Brings today's funeral announcement. First, these words.
Variety of payment options designed to fit your budget and lifestyle as well.
Okay, next thing is we want to slowly bring it up some more. I'm going to move my ground wire
1407 Fort Lamar Road in Commerce. We'll be happy to tell you more about our local
to the
program.
ground
Make sure you ask about our special.
here.
That's Bill Yancey Commerce.
And so half the voltage, which is what I expect to see. So the next thing we want to do is bring it up a little bit. Notice it coming in better. Now the tubes are driving, the B plus is up. I'm at 92 volts. But what I want to do is check the B plus. So we'll check the B plus on the rectifier and see what we got coming out. At 305 volts B plus, that's good. On the tubes we should have, let's see, on these here, we should have 200 volts. That's not the right pin. Let's see, what tube was it that I was counting? I'll try these here. Okay, we're good. We're supposed to have 200 volts. I'm only at 92 volts on my Variac. And this is the shield, 67, 267. So the, lower that. It's working fine on the 6D6. We should have 200 volts on the plate and 80 on the shield. So let me find the 6D6. Okay, it's right here. If I can get in there. Let's try it. I need a light in there. Okay. Got too much junk in my way here. My desk is just full of clutter. All right. On the plate. I have 175 volts. On the shield, we have nothing. I need the shield. I'm on the wrong tube, I think. 66, the RF tube. Let me get my eyes on here. This print on this tube layout is very dim. All right. Oh, that ain't it. That was on the wrong one. Sorry about that. 6D6. Oh, way back over there. Okay, that's that one up there. We know the danger zone there. So we'll try that again. And that's a better place to check it anyway. Okay, this is the screen grid. And we got 67 volts. And on the plate, we should have the 195, 163. Okay. So we're getting good voltage. The numbers are fine. Not seeing any problems. Let me check the 45 tubes. According to them, on the filament, on the plates, we should have 375. On the 45s, they should all have 375 on the plate, and well, the filament, we're not going to worry about the filament voltage, but we could check them. Okay, so on the plate, $285, and we should have 375. Again, I'm not all the way up in voltage, and on the filament it's 60 volts, but that's AC. I'm getting 36 volts. Okay, so there is DC volts on filament. Interesting. So we're getting 36. So let's go ahead and bring the voltage up. See what the milliamp is. We're drawing less than an amp, 0.93, and we've got 81 watts. That's a lot of watts, but this is 13 tubes at 92 volts. Let's see if that label says anything about the current draw. 157 watts. See it there? So it's 157 watts, and we're drawing 81. So we're doing great. So let's bring it up. Okay, now we're at 110. That's fine. That's perfect. 1.8 amps, 122 watts. Now we'll have really good reception. I may not even really need to align this. It may be still in alignment, but we'll check it. Okay, that's the other side of the band. Now let's go back. This is the AM band here. This is my local station. Wow. That's all I got to say about that. That speaker is amazing.
Georgia did that. They actually put the and used.
Okay, well, this radio is back in good shape.
Consider a donation for 2020 by contacting Judy Granger, 706-892-6507. To send your check to United Way of White County at P.O. Box 1288, Cleveland, Georgia, 30528. We would greatly appreciate your support.
How many times has a customer or potential customer called for business and been put on hold? What are they listening to?
Okay,
You certainly don't want
so
them to enter the twilight.
what we're going to do now is solder these in so I can lay this unit at a different angle